Hi everyone, in this video I am going to introduce a Verilog HDL. So in the previous video we have discussed the VHDL coding and what are the different data types, data objects and what are the different operators, packages, libraries, all we have seen in the case of VHDL. So now we are going to see the modeling styles of Verilog and what do you mean by this Verilog coding and how to write the Verilog code for the same examples like adders, full adders, off adders and so on. Okay, before going into the implementation, first let me explain what do you mean by the Verilog HDL. So Verilog HDL is basically the second type of programming language, hardware description language, which is somewhat high level language compared to VHDL. In VHDL there are actually two modules like entity and architecture, but whereas in Verilog we don't have any two modules, only single module is there. So module, it's like it is having a single module like a module. So module and gate, and we are having the code inside it. Okay, it does not consist of two different parts of the programming technique like VHDL. So designers of application based integrated circuits, so like ASIC, designers of the ASIC use hardware description languages like Verilog's HDLs. So designers of ASICs, so ASIC is nothing but application specific integrated circuit. So this is an integrated circuit which is meant for one particular application. Use hardware description languages, hardware description language at key steps in design flow of circuit, in the design flow of a circuit. So those steps are, so the first one, development of HDL model, development of HDL model, development of HDL model synthesized into physical circuit. So first we are writing the hardware description language code for any type of the circuit. Second one is we are going to synthesize that into a physical circuit. So synthesized into physical circuit, and then verified for functionality, timing and fault coverage. See here, when you are going to design a hardware description language, any circuit using this hardware description language, three steps we need to follow. One is development of this hardware description language model for the given circuit, and the second one is synthesized into physical circuit. See, once this is completed, later we will go for simulation, and in the simulation if we get the correct results, then the next step is synthesizing. In synthesizing, we are getting the physical circuit in terms of gate level. After that, we are going to verify the functionality of that, and then timing, and then any errors are there that we are going to identify. And next, HDLs have additional features. Hardware description languages are having additional features for modeling additional features for modeling and simulating the functionality, simulating the functionality of combinational or and sequential combinational and sequential circuits. Okay, so when you are going to simulate this combinational sequential circuits where its functionality using this HDL models, they are having some separate features. So they are like IEEE standard libraries are there, like your VHDL. So Verilog has IEEE standard, IEEE standard like your VHDL code. So using an HDL, using an hardware description language, the first one, a text based description model of a circuit is written. A text based description model, a text based description model of a circuit is written. Okay, that means we are going to write the HDL coding for any circuit in terms of a code, in terms of a text. Compilation of description to verify syntax. Compilation of description to verify syntax. Okay, so once the code is completed, next task is to verify the syntax. If any syntax errors are there, program will not run, it will not get simulated. So first we need to verify the syntax. So simulation of the model, simulation of the model to verify the functionality of the design, to verify the functionality of the design. Okay, so Verilog HDL serves as a, you can say it's a vehicle to serve the designing, verifying and synthesizing a circuit in a small, in other words we can also say, in other words we can say HDL is a vehicle, HDL is a vehicle for designing, for designing, verifying, for designing, verifying and synthesizing a circuit. Synthesizing a circuit. So it is also a medium for, it is also a medium for exchanging design between designers, design between the designers. So another important point is Verilog HDL supports, now coming to this Verilog HDL, so very important point here, So Verilog HDL supports Verilog HDL supports three kinds of modeling styles. Three kinds of modeling styles. The first one is gate level. Second is data flow, and third one behavioral model. Okay, so the gate level and data flow both are used to model combinational circuits. But you come to the behavioral model. Behavioral model is especially used for both combinational and as well as sequential. Used to model both combinational and sequential circuits. If you remember the VHDL coding, there are three different styles of coding techniques available: structural model, data flow model, and behavioral model. So likewise in Verilog HDL also we are having three different styles of writing a program: gate level modeling, design, data flow modeling, and behavioral modeling. Data flow model, gate level model, these two are a basic level and they can be used to design or construct hardware description language for combinational circuits. But whereas the behavioral modeling is especially used for combinational or as well as sequential. So both gates can be implemented, both the circuits can be implemented using this behavioral model. So in the next video I will explain about what do you mean by gate level, data flow, and behavioral modeling. Thank you.